Hello everyone, this is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss about few very important questions in academic point of view from your question bank on linker list, types of linker list and their applications. Let's start with the basic definition of what a linker list is. A linker list is a linear data structure where data is not stored in any contiguous memory locations. Yeah, you heard me very clearly that the data is not stored in contiguous memory locations. So whenever there is huge data and the system is not capable enough to provide contiguous memory locations, we opt for linker lists. So there are three types of linker list: single linker list, double linker list, and circular linker list. In exam point of view, all the three are very important and the highest priority is given to the basic concept of linker list, which is a single linker list. So let us start understanding the things from the single linker list point of view. Right. So coming to the three various types of linker list, there are three, as I said: single, double, and circular. Whenever you get a question on demonstrate the working or the operations on one of these linker lists, please mention the picture of draw the picture of these linker lists and explain it briefly in few sentences. In cut short, you have to explain the things. For example, whenever they ask you about what a single linker list is, please do mention that it is a non-linear data structure. It is a linear data structure, but where data is not stored in contiguous memory locations, right? And please mention that it runs only in forward direction, whereas a header or start node is a node pointer which holds the address of the first node, and the last node's next part will be stored with none or null to point out that there is no next node after it and this is the end. So coming to the exam point of view, mostly they will be concentrating on the differences between one of the two, right? One of the two pair of linker lists, say a difference between single and circular, or single or double or circular. Okay, differences is one of the important questions which you can find in your question bank. And coming to the applications, yes, they'll be asking about applications of these linker lists, which we'll see now. What are the basic applications of linker list? And coming to the description of and one of the important questions is a demo on a double linker list. How data is present, how data is inserted, and all the stuff, right? Let's go through that. Coming to the basic concept of single linker list, data is always stored in the form of a node, right? And each node have two parts. One is the data part and the other is the link part. Data part, obviously it holds the data, whereas the link part holds the address of the next node, right? So, and the next very important point is the head or the start, which holds the address of the first node, right? As it is a structure in terms of chain, and linker list do not have the index values on their heads, just like your arrays. So it is highly difficult to figure out where a particular positioned element exists. So whenever, whatever operation you do, either search, insert, or delete, you have to start from the first node only, as we have the address of only the first node with us. Okay, fine. Coming to the basic operations. Basic operations are have to create a list, traverse through the list, insert a node, delete a node, concatenate two lists, are the basic operations that we perform. It can be single, circular, or double. Okay, so coming to the creation of a node, basically a node, starting with a node, I'll take the help of Python code. Yes, guys, even you can go with that, because in your curriculum, data structures is the concept in the theory part, whereas data structures using Python is present in your lab. So as you're going to learn Python to implement data structures, you can take the leverage of the same, and using Python bits and pieces of code, you can explain the functionality of any linker list. any type of the linked list. Okay, for all the linked list, creating a node will be the first class, followed by the other class which holds all the remaining functions. Okay, let's start with the first node. Here the first node, what it tells is a node will have data part and link part, as I said. So the class constructor of this class node will have data as the parameter and two parts, data and next, as its member variables. From the argument, data will get the value, whereas next is initialized with the none, specifying that it is not linked to any other variable. Okay, coming to the constructor of our linked list, what it says is, guys, the start. Initially, the start is filled with none to say that the only the pointer is ready, that is the header or the start pointer is ready. Linked list is not yet created to specify that. Okay, coming to the creation of a linked list, a single linked list specifically. So say if you want to create 3 nodes. Here I have read the value of n as 3. So 3 times my file loop is going to run. It is divided into 3 steps broadly if you write an algorithm for the same. The first step will be reading the data. Second step will be creating a node for the same. And the third step is divided into 2 different cases. Okay, 3.1 and 3.2, my dears. 3.1 says, the 3.1 covers a case where the single linked list is not yet created. Not yet created. That is, the node which you have created just now will become the first node. So store the address of the new node in the start, specifying that it is your first node. The second case is the case where you have handful of elements. Few nodes are already there in few nodes in SLL. Roughly I'm saying that. Okay, so you have handful of elements in your single linked list and you want to append the new node to the existing linked list. I hope you know the meaning of append operation. But without specifying the position, by default inserting the element at the last is nothing but appending, right? So as we have the address of only the first node in our hands, give a name temp to that, and while you reach the last node, that is, as I said, the last node has an explicit feature of saying that its next part is none. So unless you reach a node like that, you keep on hopping using the while loop, and then store, whenever you reach that place, store the address of the new node in the next part of the temporary, thereby you are appending it, right? So this is how we create a linked list, a simple append operation. Okay, so while creating, you can have a case where it is none, the start is none. In that case, the node which you are going to read now will become the first node, and I'm going to store the address of the first node in the start. Guys, if you get a question saying that explain the functionality of creation of a single linked list, my suggestion would be either adopt a Python program or write an algorithm for the same. Okay, if you know the logic, you can easily convert that into an algorithm. Okay, once you convert that into an algorithm, pictorially explain the same. If you explain with addresses, together with addresses, then it's well and good. Well and good. Seriously, you can expect highest marks. Okay, so guys, if you want to go deep into how to create a single linked list and how to perform the insert and delete operations and all, you can follow our videos where we have explained each and every case through animations and through Python codes separately. Okay. What the second case of creation? See, have to insert an element at the tail, right? At the tail. So if there are 2 elements you want to append, that is inserting the element at the tail, name the first element as temporary and keep on hopping unless you reach the last node. Once you reach the last node, store the address of the new node in the next part, right? So guys, understand the things easily. Working with linked list, you feel that it is difficult, but it is quite easy if you involve yourself. Place yourself, think yourself that you are at a place, say, you think like a compiler or an interpreter and start tracing the program, you'll understand it. This is a suggestion which I give to all my students always. Whenever you find a difficulty in writing the code, or if you get any error, think like a compiler, where it is going to start its compilation, right? So where it went wrong, you can trace it very easily, errors, and you can rectify it by yourself without anybody's help. Seriously, if you try it, guys, manually try to evaluate the things. The animations over here which I have present does the same. They manually do the things, right? So with addresses, with the naming and all. Okay, right. So types of operations that we perform on a single linked list. Insertion, addition. Sorry, insertion and deletion. Both have three different cases. Or you can say three subcases for both. The subcases are inserting a node at the first or at the beginning, or inserting a node at the tail or at the end, or inserting a node at a given position. These are the three different cases which we encounter in case of insertion. The same with the deletion also, right? So deleting an element pointed at the front, at the end, or an element at a given position. Okay, so three different cases for both. Okay, let's look at the insertion of node at the beginning. Guys, for single linked list, I give you a demo how to write the answer. For the circular and double, please try to follow the same rules which I tell you. So whenever they ask you to write the pseudocode for inserting a node at the beginning, write the code first of all, right? So write the pseudocode which I have given, which is actually a Python piece of code, which can be converted into a pseudo one, right? So you just mention it. So you are going to read a data, create a node, then check if the list is existing or not. If it is not existing, this node will be the new node. Will be the new node, will be the first node. Else, if you have handful of elements, then what is the logic, right? So have a look at the animation which I have provided. If they ask you to simply explain how an element is inserted at the beginning, then please take the help of pictures and addresses. Guys, in case of linked lists, addresses plays the vital role. If someone asks you write something, write the insertion operation in an array, so you are going to read an array, and obviously by default you will be writing the index values on its head. Am I right? So index values plays a very vital role in a case of arrays. Similarly, addresses plays a vital role in case of linked list. There, mentioning an element with its index value is the funda. Here, retrieving the data or working with the data using addresses is the key point. Okay, so please, if someone asks you, please do not draw the blocks and put the arrow marks and just say that job done. Never ever do that. Okay, please mention the addresses. Only if you pinpoint the answer with the address part, then the third party who is going to correct your scripts will understand that you're not a novice to the concept. You understand the things, right? Okay, come back to this part. Have to insert an element in the beginning of a single linked list. First of all, very simple. Store the address of temporary in the new node's next part. New node's next part is this part, right? Store the address of temporary. The address of temporary is 2000. Overwrite the none, which was actually present, with 2000. Thereby, you are creating a relation between temporary and the new node, right? Once you do that, store. Our task is to insert the element in the beginning, and start is the pointer which holds the address of the first node. Good. But actually now if you look into the second picture, it is holding the address of 2000, which is supposed to be the second node now, right? So store the address of new node in the start. Override 2000 with 5000. Then you'll get a link between the start pointer and the new node. And the new node now behaves like the first node of the single linked list, right? So similarly, inserting a node at the end. So this one we have seen while creating a linked list, right? So appending. End means inserting any element by default at the end is nothing but append, right? That's what. Have a look at this one. Here I have elements 21 and 22 in my hands. I'm supposed to insert 20 at the end. That is, the final list will look like this: 21, 22 and 20. This is the one suppose you have to do, right? Very simple. Give the name temporary to the first node and take the hops unless you reach the last node. Once you reach the last node, store the address of the new node in temporaries next, right? So I have placed the address 5000 in the next part of temporary. Thereby you can say that the node is inserted at the end or at the tail. Important one is inserting a node at a given position. So in this case, you have to say that you do not cover the cases of inserting at the beginning or at the end. I'm going to take the help of a count function, which is going to return a value c, which is nothing but the total number of the nodes currently present in the linked list. So whatever position you are going to read, it should neither be 1 nor c. 1 means inserting at the beginning. C means inserting at the end. Right? So it should not be that. If this condition satisfies, take two pointer variables and see that temporary is the name given to the node or the node which is at the given position, and previous is the name given to the node which is just behind the temporary, right? Once you do that, you can build a relation between previous and temporary, including the new node, right? Insert the new node between previous and temporary. Have a look at this picture. 21 and 22 are the data items, but I want to insert a node with the data 20 in between. So this is the final list I want. So 20 between 21 and 22, that is the position is 2, right? So I'm going to take temporary and previous in such a way that temporary is the name given to the element at the current second position and previous is one step behind it. Now build a relation. Very simple. Just 2 steps. Previous next part will hold the address of the new node, whereas new node's next part will hold the address of the temporary. Very simple. Thereby you are going to break the direct relation between previous and temporary node. Right? Thereby you are going to insert a node at a given position. Right? So this is your inserting at a given position in a single linked list. Coming to deletion, deleting a node at the beginning. This is a small function for the same. First of all, in case of deletions, you need to take care of one thing, my dears. You need to see that the list is existing or not. If it is not existing, then there is no point in deletion also. So check if the start is equal to none or not. If it is none, just simply say that empty and return. You can return. Else, that means if you have a handful of elements, then what you are going to do? Very simple. Name the first element as temporary and make the temporaries next as the new start. Have a look at this one. So my task is to remove the first node, which is 21, right? So what I'm going to do is I'm given the name as temporary and the next element's name as new start. Then self start will hold the address of the new start. Very simple. Self start will hold the address of the new start. Thereby I'm breaking the relation between temporary and the new start. By using simple statement del temp, you can free the memory which is actually allocated for temporary. Okay, fine. Next, deleting a node at the last position, right? So to reach the last position, you have to take the hops, right? So I have taken the hops in such a way that the last node will get the name temporary. Say this is in due course, you got to such a position that it's a, this is the last node. Okay, so last node will get the name temporary, and it's just a previous node will get the name previous, right? While loop is meant for that. Then simply make the previous next as none. Thereby you are breaking the relation between previous and temporary, right? That means previous is not pointing to temporary now. Thereby, the memory which is allocated for temporary can be freed easily, right? So that's what I'm going to do. So here I want to remove 22. My agenda is to remove the element at the last, right? So I've made such that I have written such that I've taken a while loop in such a way that temporary is the name given to the last node and previous is the name given to the last but one node. Okay, so I have placed none in previous next, and thereby I have removed the broken the relation between previous and temporary. Okay, as I said, linked list is totally the game of addresses. If the node's next part holds certain address, it is going to blindly link to that element and say that this is my next node, right? Very good. Coming to the deleting a node at a given position. Even here, I just want to say that the position which I am going to read should not be neither 1 nor C, right? It should not be an element at the beginning nor the last element, right? Only in that case, I'm going to delete an element at a given position. So now see that temporary is the name given to the element which you want to delete. Okay, position. That's what. See, here I have three elements 21, 22, and 23. I want to remove 22. So if I have to remove 22, the name should be like this. As I said, whatever the node which you want to remove, we must get the name temporary first of all. Once you get that, make temporary next. Whatever the temporary next value is, address is, place it in previous next, which is 4000. Now, previous is pointing to a node at location 4000. Right? Even though temporary is also pointing to a node at 4000, it is nowhere linked to the single linked list right now. So if you write a del of temporary, that is removing the memory allocated for temporary, it will remove that memory allocated for that node, and thereby it will vanish from the picture of single linked list. Okay, so this is how we are going to delete an element in a single linked list at a given position. The next is display or traverse. So display or traverse, first of all, you have to check whether the list is existing or not. If it is existing, only you can traverse, right? So start from the first node and start traversing till the end, or the node which is whose next part is not none. You take the hops, and while taking the hops, please print the values which is present in the data part. Till now we didn't touch the data part. There was no point in touching the data part, right? Once if you want to display, that is, you are trying to project what is the element present and what is the next element connected to it, right? So now I'm retrieving the content in data and I'm just displaying the same. Okay, so this is display or transfer function, guys. So the drawbacks, as I said, one of the most important questions is drawbacks of linked list. Drawback of linked list is extra space which it takes, right? Every node is going to hold the address of the next node. So the amount of memory which is required to store the address is very high. For example, say the address takes 4 bytes of memory and you have 100 nodes, right? So 400 bytes will be wasted just to store the address only, right? That is one of the drawbacks. And the second drawback is, Single linked lists are only forward in direction. Once you take a hop, that particular node, wherever you are standing right now, will hold the address only of the next node. You cannot backtrack, you cannot go back. That is the basic drawback of linked list. Basically, single linked list I'm specifically talking about. Okay. And the third drawback is random access is not possible, just as we do in case of arrays, right? The most prominent point is get the index value, retrieve the data. You need not start with the first node, first value in terms of arrays. But here we don't have the concept of index values. So random access is not possible. As random access is not possible, we cannot implement any cache memory using this. So you cannot design any CPU cache using linked lists. Okay. And binary search operation also you cannot perform using linked list. What binary search tells? Always break a list into two halves, right? Check the element at the mid position, right? So it was quite easy with the arrays because we had index values in our hands and we used to take the average, right, to get the midpoint. But here we don't have that. So binary search is not possible, right? These are all the drawbacks of linked list. And one of the important question is difference between arrays and linked list is one of the important questions in exam point of view, guys, right? Coming to the next linked list is circular linked list. Circular linked list overcomes the drawback of normal linked list, which is once you reach the last node, you cannot go to the first node. If you want, you have to start from the scratch. That is, retrieve the address from the head or the start. But circular linked list overcomes that concept. That is, the last node will hold the address of the first node. Thereby, last node is pointed to the first node. This is the advantage of circular linked list. Still, it suffers with the drawback of unidirection, right? So this is circular linked list. Coming to double linked list, it overcomes the drawback of even circular linked list. That is unidirection. That is the main drawback, right? It is going to overcome that by modifying its node structure. It is going to modify node structure. Previously, a node had two parts, right? That is the data part and the link part. Here it is going to have three parts, where the center part of the node will be data, whereas its left part will hold the address of its left node, and next, that is the right side part, will hold the address of the next node, right? So this is the structure of the node. By modifying the structure, every node now holds the address of its next element as well as its previous element also. So you can run forward as well as backward also. Yes, it suffers with the storage, the amount of memory which is needed to store. See, if 4 bytes is the amount of memory which is required to store, so each node will need 8 bytes, 2 addresses space. So if you have 100 nodes, then as a total 800 bytes will be wasted only to store the addresses. Yes, wastage of memory will be more, but time complexity will be less. Okay, as you can run here and run. But one basic drawback is any linked list. You take any linked list, a double, circular or single, cannot be used for cache memory because cache memory needs fast access. It is meant for that. But linked list, the amount of time required to hop from one node to the other node, retrieving the addresses and jumping, it takes a lot of time. So cache memory can never be implemented using linked list. If you implement with that, the basic agenda of having a cache ruins. Okay, so that is the story of double linked list. So pros and cons of double linked list and applications, which is very important question in exam point of view, right? So the pros are the straight and forward one is you can travel in forward as well as the reverse direction. Okay, as every node holds the address of both the its neighboring nodes. The con is the drawback is storage. As I said, it needs 4 to 8 bytes of memory to store the addresses. Okay, coming to the applications, wherever you go for playing videos, sound files, rewind, you go back, right? While watching something, you rewind the things, right? So for that, double linked list will be used. Anything, any places where you want to run forward and backward, you go for a double linked list. And one more, if you come to the differences between arrays and linked list, then you can say that yes, the basic disadvantage will be advantage with arrays is insertion and deletion. Insert plus deletion is quite easy in case of linked list. It is highly difficult in arrays. In arrays, we have to move the data left or right to insert, to delete and insert respectively. But in case of linked list, you are not going to change the positions or the addresses of any node, but just changing the link paths, overwriting the content of the addresses with the other addresses. You can simply insert or delete, which we have seen in case of single linked list. When we deleted any node or inserted a node, did we change the structure of the remaining nodes except its neighbors? We didn't touch it, right? But in case of arrays, if you delete an element, you have to push all the remaining elements next to it towards left, right? So it is a tedious task. So these are the few drawbacks, and they are very important in exam point of view, my dears. Okay, coming to brief intro to the applications of linked list. So in representing polynomials, whatever the operation on polynomials you want to do, you can do with the help of linked list. So in case when you use linked list, as I say node, it will have three parts now. A polynomial have coefficients and exponents, right? So both must be stored. Both are important. For example, take an operation 4x square minus 3. This is a polynomial. Add it to 3x square plus 2x plus 7. Say this is the example. How we are going to add? So based upon the exponents, if they have same exponents, add the coefficient, because adding is your primary operation. So 4x square plus 3x square, 7x square. Okay, so to add 2x, you do not have that component in your first expression, right? So replace it as it is, plus 2x. Coming to the constants, minus 3 plus 7, which is plus 4. So this is the result. Based upon the exponents, even with the constants also, you can say that the exponent value was 0. Am I right? So 0. So you match it that and you have added it. So exponents plays a vital role in terms of expressing any polynomial, right? So you are going to work with coefficients only if your exponents match, right? So storing them is very important. So my node structure has been changed into three parts now: coefficient, exponent, and the address of the next node. So this is how I am going to store. Take a look at the expression which I have taken, polynomial. So 4 is the coefficient, 3 is the exponent, 6 is the coefficient, 2 is the exponent, 10 is the coefficient, 1 is the exponent, 6 is the coefficient, and 0 is the exponent, right? If a term is not there, kindly store 0, but do not leave that place. Okay, so this is how we are going to create a polynomial for storage purposes by using single linked list. This is one of the major applications. Yes, okay, then have to create it with the help. If you get a question to create a polynomial, then take the help of a Python code and do it. This is a piece of code. Have a look at the structure of the node, that is the constructor of the class node. It is having three parts: coefficient, exponent, and next. And in the constructor of the class polynomial, start is specified or initialized with the value none, just as usual. Coming to the creation, read the coefficient and exponents and then create a node. Okay, so this is how we are going to work with the polynomials. Now to create it. Okay, so you are going to store the store or this else, but it will tell you that I have adopted append operation. I'm appending. Now it is in the hands of the user how he enters the data, right? How he or she enters the data, starting with highest exponent or the least exponent, right? So, guys, if you want to work with polynomials using single links, take a format in your mind. Please never give an entry like 3x square minus 4x cube plus 2. So, where try to see that you start with a higher index value and run towards the constant, that is 0th index one, right? So please follow that, a descending order. That will be quite comfortable to work for you or for user friendliness. The way you design the program, it is going to work in that way only. No point of any doubt in that. But the condition is for your understanding purpose, I'm saying this. So enter the exponents and coefficient in terms of decreasing order of their exponents, right? So we write the programs such that they are user friendly in nature, right? For that sake. So I have to display it very simple using hopping from first node to the last node, printing the exponents and coefficients you can traverse. Okay. The next and most important application is sparse matrix. Guys, in exam point of view, applications of single linked list is very important. So please understand the concept of sparse matrix. Any matrix, if 50% and above its data is filled with zeros, we call it as a sparse matrix. Okay, so then what are the problems in working with sparse matrix? Problem is storage and computing time. So storage is a more number of zeros which are of no use. So allocating memory for them is waste. Second is computing time. So logically designing that with only zeros in hands is waste, right? So to sparse matrix, we can represent them using arrays as well as linked list. Take the example of this one. So using 4 different ways, I can represent a sparse matrix. One is array representation, where I'm going to just store the row, column, and value. Nothing more than that, right? Yes, even this is a matrix, but it is not going to store zero values. For example, 0, 1, 2, 3, 4 are the index values of the given matrix. Okay, then the first non-zero value is 3. So whose row value is 0, column value is 2, and the value which is present at this index ijth of the matrix is 3. So store the data of only non-zero values is array implementation of sparse matrix. Even that you can use do using linked list, right? Keeping the drawbacks of arrays in mind. So create a node for the data where each node have 4 paths now. You have to store in which row, in which column, what is the value, and what is the address of the next node. Okay, so this is how you can store a sparse matrix. You can represent a sparse matrix using linked list. It can be done using list of lists also. So this is the structure of list of lists, where the node value, that is the row values, are present in a array, and their corresponding neighbors will be stored in terms of a single linked list, where here the nodes structure again changes. As the row index values are stored in a list, column index, value, and the address of the next node will be the path. That is, only 3 paths will be there in a node nav. Okay, right. So this is how we are going to represent a sparse matrix using linked list? Guys, this is very important question in exam point of view. In how many ways you can represent a sparse matrix? Sparse matrix. Then four different ways. As I said, arrays, linked list, list of lists, and last is dictionary. So in Python, you know that dictionary is collection of data. It is in terms of key and value. If you know the key, you can retrieve its corresponding value, right? So using and here the key will be the combination of the row and column. And what this combination tuple tells you, this is the row and column of non-zero values. Non-zero value. Okay, so non-zero values, row value and column value will navigate you to the actual value present or the data is present in that cell. So using dictionaries also we can represent sparse matrices. So polynomials and sparse matrices are the basic applications of a single linked list, and which is one of the important questions in exam point of view also. Okay, so with this I would like to conclude that let us list out the first and foremost important question is array versus the linked list concept. Second one is a comparison between linked list, the various types of linked list which you have. Third one is applications of linked lists, and the fourth one is drawbacks of linked list. And the fifth is the generalized question, the insertion, deletion operations they may ask you. Okay, so please do remember this one. So first and foremost one is single linked list, followed by circular linked list, followed by double linked list. Okay, so with this I'd like to conclude. If you want to go deep into what are the applications, how they are implemented, all with animations we have provided in your lecture videos, which you can follow in our channel. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.